I am going to start on the yoga pose detection and validation using machine learning. So for this, we have two research paper. One is yoga pose detection and validation by Ayush Gupta, Dr. Ashok Jainred, and Delgar Education Institute, Agra, India. Another one is yoga posture detection using machine learning. So many are there they did for this research. Okay. This system combines computer vision and artificial intelligence to help users perform yoga poses accurately without the need for a physical instructor. Yoga is widely practiced for its physical, mental, and spiritual benefits, but incorrect postures can lead to injuries or long term health issues. The challenge is how can we ensure people practice yoga correctly when a trainer is not available? The goal of this project is to build a low cost, efficient system that guides users through yoga poses step by step and validates them in a real time. Since publicly available datasets were limited, a custom dataset was created. Image, Images were collected from yoga videos and online sources, focusing on four processes. Warrior 1, Warrior 2, Triangle Force, and Tree Force. That's here. Warrior 1 force means Virabhadrasana. Warrior 2 force means Virabhadrasana. Triangle force is Trikosana. Trikosana. Tree force is Vikrasana. Okay. Human force estimates. Human force estimation was done using a lightweight version of open force that works efficiently on CPU. For each images, 18 body key points were extracted and then used to calculate joint angles and distances. These served as features for the model. Each yoga pose was divided into steps like standing straight, raising hands, or bending the knees. In Virabhadrasana 1, Warrior 1 pose. In this, stand straight in attention position. Second step is keep your hands on your waist. Third step is spread your legs apart. Fourth one is twist your body and raise your arms up. Then bend your forward leg into a lunge from forming a 90-degree angle. Warrior second pose, that's Virabhadrasana. Stand straight in attention position. Keep your hands on your waist. Spread your legs apart. Then turn your foot and scratch your arms straight parallel to the ground. Next, bend your knee towards the ankle. Trikonasana, that's triangle pose. Stand straight in attention position. Spread your legs apart. Stretch your arms straight parallel to the ground. Bend your body to one side. Touch the foot with the hand while keeping the arms straight. Vikrasana, tree pose. Stand straight in attention position. Keep your foot over the thigh of the another leg. Stretch your hands. Then joint your hands in front of your chest. In this research paper, the contribution of forces in the dataset, yoga force and contribution in dataset. Tree force contains 15.69%, triangle force contains 24.7%, warrior 1 force contains 29.41%, warrior 2 force 30.20%. The final feature set was used to train two machines learning classifiers. Okay. Support vector machine and random forest. The model were trained and tested on Google Colab using 75 to 25 train test splits. The results were impressive. The SUM model achieved an accuracy of 97.67%, while the random forest model achieved 96.47%. Confusion, confusion matrix showed consistent balanced classifier across all four poses. See the confusion matrix. This is normalized confusion matrix for random forest classification model, and this one is for normalized confusion matrix for SUM classified model classification model. The system runs on basic hardware, a standard RGM webcam, a mid-range laptop, and no GPU is required for this. This makes it cost effective and accessible for everybody users. And another one paper set is given this. In this, they used the different type of models like VGG16, VGG19, MobileNet and MobileNet V2, Inception V3 like this, and they got the sensitivity and specificity and MCC. For VGG16DA got 94.90% and specificity is 99.60%, MCC 0.9446. For VGG19DA 94.90% sensitivity and specificity is 95.60 and MCC is 0.9425. For MobileNet DA sensitivity is 98.43%, specificity is 97.60%, and MCC is 0.9831. MobileNet V2 DA for this sensitivity is 92.16%, specificity is 95.65%, and MCC is 0.911. Last, Inception V3DA 91.76% of sensitivity, 93.62% of specificity, and MCC is 0.91. See, exciting solution model, and this is methodology. Working on They worked on the application of model and ForceNet model, key points detection, skeleton formation, see the skeleton formation, and confidence score, data collection, data augmentation. They did the data collection, then data augmentation, key point detection, ForceNet model estimation, and model evaluation. Data flow diagram. This is okay. Conclusion features for work. Okay. See the outputs of this model. Skeleton body. the see the output of second force, output for the third. Okay, to overcome this, we build a model. In this, we have a dataset of yoga force image classification dataset from the Kaggle. This contains many folders. This file contains many folders like this, and they have different classes. And yoga force names like Adhumukha Savasana, Adhumukha Vikrasana, Agnistamba Asana, Ananda Balasana, Ardha Uttasana, see Bhairavasana, Bakrasana, Bhujangasana, like this. So many classes are there, and we use this data set and we build a model. Say that classes now I took from that classes and I uploaded here. Then I did an data set balance and pre-processing. Then preparation. After that, splitting data set, including label mapping, training and scale saving. Then model validation. Okay. See, this is the pre-processing and saving with subclasses. Next, we got image distribution by class, and this is the subclasses of yoga force. Adho Mukha Savasana, Adho Mukha Vakrasana, Agni Stambhasana, Ananda Balasana, Anantasana. Then we build a efficient model. In this, we did an hypothesis. See, first we got loss of 12.76161, accuracy of 0.0432, validate loss is 4.0232, validate accuracy is 0.1547. Then final we got 0.3772, accuracy is 0.9773, validate loss 0.3103, validate accuracy is 0.9812. That's far better than research paper. Okay, we got a graph showing like this training and validation loss versus epochs, and another one is training and validation accuracy versus epochs. Okay, and we got an test accuracy 0.9771 percentage, 0.9771. Confusion matrix is, and also grade cam image in original image like this, and grade cam hit map and hit map overlay. Okay, after that we did an application for this model containing yoga detection using histological images. Or source yoga detection using histopathology images. We can able to classify the yoga. Okay, click here for the classification of yoga model pose. Please upload the clear image. Okay, choose file. Choose the file. That means we have to upload the image. Okay, take any one image. Okay, first one you see which one is this. Okay, predict. It will predict the force. Which force is this for yoga classification? See, we got the yoga position analysis. Adho Savasana, yoga position detail. Yoga position is Adho Savasana, and benefits of this position is stretches the entire back, hamstrings, and calms the mind. Classification basis, inversion and forward bend. See the image. We'll see another one first. Upload the another one image. Okay. Predict the position. See, Baddha Konasana. Yoga position is Baddha Konasana. Benefits of this position is opens the hips and groin, calms the nerve system. Classification basis seated hip opener. And another one we are going to see. We will upload the another one image. Okay, predict. Ardha Utthasana. Yoga position detail is yoga position Ardha Utthasana. Benefits of this position is length, lengths the spine and hamstrings. Prepares for deeper forward bend. Classification basis standing hop forward bend. Okay, we'll see another one class. And predict Ardha Bekasana. Yoga position is Ardha Bekasana. And benefits of this position is stresses the front body and strengthens the back. Stresses the front body and strengthens the back. Classification basis front and back bend. See another one last. Okay, predict. Anjaneya Asana. Yoga position detail. Anjaneya Asana benefits stress hip flexor and thighs. Improves stability. Classification basis lung and back bend. Okay, we did this much of explanation. If you have any doubts and you want any detail regarding this project, and if you want code, you can contact us on the WhatsApp number we have given inside there. Okay, thank you for watching.